Good afternoon, everyone. My name is Bob Levy. I'm CEO of Immersive Analytics, formerly known in parallel a Virtual Cove company. How many of you have tried our Virtual Cove data visualization demo outside? So a few. Awesome. So I built my career inventing, commercializing a number of different technologies with data analytics companies, IBM, MathWorks, a lot of technology development and product line management experience. Came together around this concept of data in an immersive space in 2015, and we've been working on this ever since. So Immersive Analytics, and this is the only commercial plug, really we bridge the gap between operational enterprise data systems and some new possibilities that I'll share with you in this talk. It turns out that the obvious thing people would expect from a headset is plots in 3D, and what would three dimensions give you? So it would certainly give you more space to see more records of data. So one of the examples, portfolio managers looking at a wider universe of stocks and financial instruments. It turns out that when you have a plot in 3D, it also gives you an extra axis, the z-axis, x, y, and z, so you can see another factor about the data. But this talk was beyond plots in 3D, and let's talk about some of the less than obvious things that we found over the past few years. So what we found is that the obvious, back in 2015, so plots in 3D, it wasn't enough to get people in business settings. These are Excel users, people who use spreadsheets for a living. It's a very interesting thing to ask this kind of a user to put this device on their face. And it turns out that to get adoption of this technology, we had to go well beyond plots in 3D to do something quite different. So one of those things is actually getting dimensional perspective of data. So one of the examples we've been showing today outside, you can try it for yourself, is the use of a form of special effects as a new kind of axis for data. So what's interesting is there's a lot of work in neurology around properties of the immersive experience versus the flat screen. And it's actually been shown under functional MRI that different pathways of the brain become active. And we believe that explains why we're seeing some of the strong results that you may have seen demonstrated outside. And finally, immersive space gives us completely new structure, a completely new spatial palette to arrange data to represent different kinds of data structures that haven't been shown before. So let's walk through a series of case studies of where this turns out to be very important. So imagine you're a trader or portfolio manager in the financial markets. We do a lot of work with the financial markets. These folks have a lot of screens on their desktop. And it turns out the reason for that is they're looking for perspective, different angles or contexts on financial markets. So what's really interesting from a human factor standpoint is this human being is behind all of these screens. They're looking at that, they're looking at that, and they're trying to, in their head, stitch together what it all means, how these factors of data all weave together to tell them something that gives them an edge. And it turns out that's really difficult. So let's take a step back and use physical space to do something different to solve the same problem, perhaps more effectively. You can see this outside in our demo if you haven't seen it hands-on. So on the right, we'll show the traditional plot, and on the left, we'll show what that means immersively. So our portfolio manager is looking for an investment sweet spot. They make these decisions based on their experience. They make these decisions based on the more than X versus Y, size versus color, or 4 columns of a spreadsheet. There are a lot of nuanced factors that come into the equation. So it turns out that the plot in 3 dimensions gives us a z-axis, and it gives us more space, as we talked about earlier. Now I've done something else. On the flat screen, you probably won't see this. I do encourage you to try the demo. Here what we've done is varied translucence. So on the x-axis, we've price earnings. The y-axis, in this example, we've dividend yield. The size of each of the points is the stock's market capitalization. The z-axis is a value metric, price sales. And then how solid each point appears That's a sense of the earnings per share, how solid the earnings per share of the stock comes across. Again, on the flat screen, it turns out for interesting neurological reasons, people are not that skilled at telling relative translucence. But in an immersive space, people do exceptionally well with that. And we found a host of special effects that translate into an understanding of the underlying data. So here, translucence, or how solid the point appears, is the stock's earnings per share. Now here, we've added a glowing outline. And it turns out, so this example, it's a metric of financial health of the company. And in this, on the flat screen, as a rendering, it turns out it's very difficult to compare how much glowing outline there is around each of these data points. Yet, with thousands of people having tested the solution and looked at it in a headset, with their colleagues next to them without a headset, what we found is consistently the people who are looking at this on a flat screen say, I have no idea what you're talking about. Person who's put the headset on says, of course, these are very easy to compare. So it's very easy for the person in the headset to compare how solid the points are, how much glowing outline, and a host of other special effects that we've invented for this purpose. So it turns out that that means people in a headset are getting dimensional context of data for the first time, where people, like you're looking at a flat screen in this room today, aren't seeing the same thing. In this example, so 7 columns of data mapped to X, Y, Z, size, color, glow, and translucence. Using traditional plots, X, Y, size, color, there are 35 unique combinations. These are the 35 screens that this one distills as a single unified view. So what you're doing is you're helping the human expert get context over a much more complex set of data than they ever had a way to see before, without needing to try and remember and stitch together what's going on all these different screens, to unify it for them, to make it intuitive. So this is special effects as a new means of showing dimensions or axes or variables of data. So we've patent pending on over 50 of these. We've operationalized the first 16. At 16, we have, in production, distilled 1,820 screens, a wall of unique plots, down to that one digestible thing. That's been deployed. What's interesting here is as your spreadsheet grows, for every additional column, the number of unique plots, that number grows geometrically. So it becomes a really difficult problem for people to get their head around data at this scale. So then you wonder, well, what are people doing today to solve that problem? How many people in the room have not heard of artificial intelligence or machine learning? So we're deploying AI and machine learning at scale to try and find these patterns. Unfortunately, the AI and machine learning models, they're being developed, honed by people with PhDs in AI and machine learning, not in the domain, not in the subject matter. So what we have here is a way to bridge the gap, bridge the divide between subject matter experts and people building AI and machine learning models. So we have a case study, and it turns out that this is an example of a 16-dimensional view. You see a lot going on around these data points. Takes 10, 15 minutes to acclimate to that. What people are seeing here very quickly, though, are patterns and anomalies on whatever dimension they might present themselves. So it's a form of exploratory data visualization. So one of our case studies, we took a data set with 26 dimensions. It turns out that is 14,950 unique plots, traditional plots, if one were to study them individually. 5 minutes each would be 35 work weeks. That's a risk management data set. So we took the 26 dimensions, we distilled it down to 9 visualizations, which were studied in 3 hours. Same information coverage. Completely new patterns of risk and anomaly discovered about financial markets. So we've done this for streaming, real-time historical data. You're seeing an example. This is with a Meta headset. Video captured outside in the Media Lab earlier this, or later last year. And we also learned that the video game engines are not at all well designed to solving this problem. So we're varying many properties, but an immense amount of data, and we're doing that all in real time. And it turns out that needed a customized rendering engine in a way that can be integrated with tools people are already using. Now, I mentioned when you're in a headset, this rich perspective comes alive. It's really difficult to capture it on a flat screen. I encourage you to try the hands-on demo outside. And of course, you want to interact with, pick the points, learn more about them, investigate. So this affects as axes. It applies to different structural arrangements of data. So we've invented ways of doing this with graph, network data. Networks, of course, are very living, breathing things, so you want to connect this with real-time streaming data about a network as well. So the idea here is situational awareness for cybersecurity and intelligence use cases. Mixed reality use case demonstrating a traditional system creating or driving these immersive ways of experiencing the data. And we're also working on ways to have one system affect what the other system is doing as well. If you visit our website, you can read a detailed brief that Intel has co-authored with us outlining some of the other use cases for our immersive analytics technology. And I encourage you all, if you'd like, to meet in the hall and try a hands-on demo for yourself.
Okay, thank you very much, Bob.
Thank you.
So next we have